Here we go. Let's see, here we go. We're doing the 2008 BC multiple choice. Okay, let's see. This diverges. Okay. And A is less than BN. AN is less than BN. That sounds like greater than a divergent diverges. Okay, so let's draw a little picture. So you have AN, and this is a divergent one. And then BN is higher. This is AN. So direct comparison test. They've removed it from the 2020 AP exam. But you'll have to know it in college potentially. So it's still good for us to know. This is alternating stuff. Interesting. Well, I would say by the direct comparison test, BN diverges. And are they positive? Yeah, they're positive. Okay. So BN diverges. Interesting. Does the alternating series converge? Maybe, maybe not. What if you had the series 2 to the n? So 2 to the n, right? N equals 1 to infinity, which is 2 plus 4 plus 8 plus 16 plus dot dot dot. What if you alternated it? 2, negative 4, positive 8, negative 16? Yeah, still diverges, so I don't think that one's convergent. Bn. Bn is bigger. Okay. So I would say, does it automatically diverge? Okay, Bn diverges. Do we have a Bn diverges? We have a Bn diverges. So let's not worry about the rest of them. Okay. Oh my gosh, alternating series. Why are they giving me alternating series right at the moment? Okay, so sounds good. We already have the answer E. We don't have to worry about the rest. That's by the direct comparison test. That's exactly what I wrote up here, and it's right there. Okay, so let's not overthink. Okay, what's the area enclosed by the curves? Oh, area. Excellent. Not on the AB test this year, but it is on your test. So that's exciting. Area enclosed by the curves. Don't know what this looks like. I know it's wiggly, something like that, but that's too many curves. And then that's a line. Okay, not going to graph this by hand. I look at the decimals. Definitely not. Okay, so let's do the calculator again. Okay, and I think the calculator turns. I tried it on my other tablet and it was working, so it should work here too. Okay, so hopefully when I go over here, it turns the video. I should have checked it on one of the other ones. Okay, so let's see. Here we go. This one. Okay, let me turn it so I can see it. And y equals. Here we go. So what am I going to graph? I just took a picture. I have too many devices over here. Okay, so this is, okay, y1. I always make y1 the first thing in the equation. Somehow I keep forgetting to hit x. Okay, there we go, x. So x to the third, arrow to get down, minus 8x to the second. You can put the second or with the arrow, plus 18x. So just so I could remember, I put the first one as y1 and the second one as y2, and then I don't have to think about which one's which. Plus 5. Okay, but I'll know it's a line. I'm going to go zoom 6, go back to my negative 10 to 10. Does it say anything about quadrants? I didn't take a picture of the whole problem. I think it just said area between the curves. Okay. Well, there's two areas then. I think I'm going to change my window. I was just going to try to zoom in and zoom out, but that doesn't work on my calculator. Okay, so window, let's see. let me write on this for you. I think I can write with this pen. We'll see how this works. Okay, so I'm thinking maybe -2 over to here. It's a cubic, so it's not going to go back up. So this is what? 1, 2, 3, 4, 5, 6, 7, maybe 7. And then how high do I want to go? I want to go a little higher than it is. I think it's at 10. So let's go to 15. And then we don't need to see too much down here. So let's do -3. Okay, so that's going to be my plan. -3 to 15 and -2 to 7. Okay, -2 to 7 would be first because that's the x. So -2 to 7, -3 to 15. So I'm going to hit zoom. Oops. I think I have to okay. To select the screen, I have to click on window. So window for x's, we said -2 to 7. I like it still marked at 1s. And then -3 to 15. Okay, let's see if that's good. And then we'll graph it and we'll check. How's that look? Okay. Okay, and that's not going to loop down again because it's a cubic. Okay. I see everything there. So that's, I'm definitely going to graph that on my paper. And then I'm going to find, let me show you the values. Okay, so I'm going to find this x value, and this x value. And I feel like I'm going to do y top minus y bottom over here, red minus blue, and then here I'm going to do blue minus red. So that's going to be my plan. Okay, so I'm going to draw that. I'm going to take a picture, go back to the other screen. And actually, before I take that picture, I should probably find the values. Let's find the values where they intersect. So let me undo my pen. And let's do intersect. So I hit second and then the calc button. Intersect is number 5. And then I just hit enter, 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 usually for the first one. Okay, so, oh, they hit it an actual spot that I can write down and don't have to store. So that's 2, 7. Okay, so that's going to be probably my B. Let me do second calc again. Intersect, enter, enter. Enter, but you're going to have to get over to the other curve. Now, I don't know if you know this, but if you hit the second button and then the right arrow, it jumps by 5 pixels. So it goes faster. Oh, 510, nice. I don't have to store this. 510. If you do want to store it, though, you do second quit, you hit X, enter, and then there's your X value. And if you write Y, the letter Y, I think. Not the Y1, but I think the letter Y, yeah, it gives you the 10. Okay, but I just wrote it down because it's a nice, pretty number. Let me do second calc again. Intersect, enter, enter, and then I've got to get back over here. Yeah, definitely, I'm going to hit the second button, second. See how it jumps 5 instead? So then you go faster over here. Oh, you can also type in a number. Let me show you. I think they hit near 1. So you could just type in 1. Oops. You can just type in the number 1, and it happens to intersect at 1, but it gets closer to the to where it intersects. So it finds the real value for you. It just was an accident that it was actually 1, and that's what 1, 6. Okay, so I'm going to go back. I'm going to draw that picture. I'm going to write those numbers down so that I can show you what it should look like when you do free response. Okay, so let me go back. Change this. Here we go. Okay, so I'm going to draw the picture. Did I take a picture? I did. Okay, so my blue graph looks like it was all in the first quadrant. Okay, and then I would label. So this is -2 to 7. And then let me change the color. Okay, and my line was red. There we go. So then I would call this A, B, C, because usually A, B, and C are going to be decimals. Okay, but in this case they're not. So A was 1, B was 2, and C was 5. But usually I would put something like 1.237 ... And then they would know I was actually storing it as A. I wouldn't round because you're not supposed to round for future parts of problems. Okay, so let me erase that. It's really just 1. Okay, and then let's do the integral. Nice. When I'm shading, I feel like I could do y top minus y bottom. So that's the blue minus the red. So from 1 to 2, it's the blue, which is the polynomial. And then you could just call this y1, y2. And then it's okay for, if you label, it is okay for you to put a y1 minus y2 and then dx. That is allowed because we labeled it. It's probably better to put the x values in, but this is the calculator section anyway. Plus 2, sorry, I don't know why I was skipping to 3. 2 to 7. I feel like the curve changed, right? Isn't the red curve on the top? So the y top would be the red curve. So that would be x plus 5 minus y1. I should do y2. y2 minus y1. Okay, so I'm going to go back to the calculator, and I'm going to type that all in as one thing. I wonder what gesture they thought I was doing, because it says you can't do gestures. I wasn't trying to do a gesture. Okay, y2 minus y1. Okay, so let me get out of here. Go back to the calculator. Okay, I'm going to get faster on this tablet. Oh, that's interesting. Okay, for me, it wasn't turning it when it was upside down. Okay, so I'm going to get out of here. Now, if I wanted the last x, I could type in x, and there's the last x I had, and that was the last y I had. But we don't need it. And then you would hit store. Store in A. Oops. So store in alpha A. Let me try that again. So store alpha A if it was a decimal and you wanted to store. Okay, so oops, math 9. Okay, so math 9, I'm going from 1 to 2. Y1, I go to variables. That's y1 minus y2. I definitely don't want to type that whole thing in. y2, and this is a dx. Plus, and if you have one of the other calculators where you can't type it in that way, just let me know. Send me a text, and then I'll make sure that I show you how to do it on that calculator too. Okay, so math 9, 2. I'm used to doing the other one, so this is I'm very slow. Okay, 2 to 7. X plus 5 was y2, so that's variable y2 minus y variable function y1 dx. 2 to 7, 1 to 2. Make sure you type in the right thing to the calculator. Negative. What did I do? Because you're not supposed to get a negative. How strange. Did I do them backwards on the picture? I definitely have the information typed in. See where I screwed up. Okay. Definitely not supposed to have a negative. Let's see. Isn't that what the picture looked like? Let me look back at the picture. Let's see. Yeah, 1 to 2. The curve's on the top. And then the line is on the top, which is y2 minus our y1. How bizarre. Let me go back. I wonder if for some reason my y1 and y2 changed. I don't think so. y1, y2. That's the craziest thing. Oh, did they not really hit it 7? Oh, they didn't hit it 7. You guys are probably screaming at me, Miss Nichols, what did you do? Okay, that was so stressful. Everything I ever knew about area was just blown because that's supposed to be a 5, not a 7. Okay, that's funny. Okay, Okay. There we go. Okay, that was so stressful. That's good though. It's good because I really like you guys to see my errors. I know that sounds funny, but you have to know what to do if you hit an error. Okay, you don't just give up. It's that perseverance idea. Okay, so it's definitely important. Okay, so we figured it out. And to know it's an error, don't just absolute value it or something. Okay, so let's see. Let's go back. Let me go back. Let me go to this. Here we go. I put 5. Oh, see that's 7? I wrote that 7 a little bit too big on my label, I guess. Okay, so right here, C is 5. Change the 7 to a 5. That's way better. And it's 11.833. And is that one of the answers? 11.833. Was it volume? No, it was area. So I was good. Oops. So I'm area. So this is all good. Let's see. Nice. Good. Good to make errors. Don't stress out too much. Those are the things I check. I guess don't put your label so big like I did. Okay, so let's see. 84. Let this be a function. Okay. Ooh, third derivative. Oh, that seems like a Taylor series. Ooh, Taylor series. Okay. Taylor series. I was thinking, what else would a third derivative be useful for? Maybe to see if the concavity is increasing. Third degree polynomial. Okay, so what's the formula? And Taylor series are on the free responses here. So the formula would be f of x equals, it's f of a plus f prime of a, x minus a to the 1 over 1 factorial plus the second derivative at a, x minus a to the second over 2 factorial plus f triple prime of a, x minus a to the third over 3 factorial. Let me change colors. This screen is too light. Okay, so what's a? A is 3. So f of x, and I should put approximately because I didn't put a dot, dot, dot. So approximately f of a would be 3. F prime of 3, x minus 3 over 1 factorial plus f double prime of 3, x minus 3 squared over 2 factorial plus the third derivative. Yeah, I don't have any space over there. 3x minus 3 to the third over 3 factorial. Okay. And what's that? F of 3? F of 3 is 2. That's 2. Let's not make that look like a negative. Okay, let's erase. Okay. Negative 2 equals 2. Okay, f prime of 3 is negative 1. So that's negative 1, x minus 3 over 1 factorial. 1 factorial is 1. F double prime of 3 is 6. X minus 3 to the second over 2 plus the third derivative is 12. X minus 3 to the third over 6. They don't have the factorials in the answers. Okay, so this would be 2 minus x minus 3. I'm not going to distribute it out because I think their error they made on this is I think they made them at x equals 0. Okay, because they didn't put the parentheses. Okay, plus 3, x minus 3 squared, plus 2, x minus 3 cubed. So let's see. 2 minus, those two look good. All these look good. 6, no. 3 looks good. 3 looks good. I have a 3, not a 4. Let me make sure. This is a 6. That is a 12. Okay, I like this one. Oh, that's a nice question, right? You just have to remember your Taylor series. That'd be nice. Free response? Please give me some of those, right? Okay, 85. A particle moves on the x-axis with the velocity given by v. For the t's, how many times does the particle change direction as I go from negative 3 to 3? Okay, so I'm going to treat this as a graph given problem. Changes direction. That means I want to go from right to left, from left to right. Okay, so that feels like velocity. I need a velocity number line. Okay, so how am I going to get a velocity number line? Well, to get a velocity number line, I'd love to have a velocity graph. Okay, so that's my favorite. My favorite is if I'm making a number line, if I have the graph the same exact one. And then I'm going to go from negative 3 to 3. Let's see if I can do this better than that last one. Negative 3 to 3. So I'm going to graph V. They gave me V. I need a V number line. So that's going to be above and below. Okay, because it's the Y value of the V graph. If I wanted an A number line, it would be the slope of the V graph. Okay, so let's see. So I need to graph that. That's a polynomial. Okay, so let's see what it looks like. Let me take a picture. That picture thing is working really well. So I'm taking a picture using my phone so that when I change pages, I can still see the problem. Okay, so let's see. It takes a little being inventive here to do this online. This time let's just go directly to that. There we go. Okay, that's faster, except that's not the one I want. Okay, this is the one I want. Okay, so let's see. Let's see my equation. So my equation is, let's go back to y equals, clear. Okay, that one is 3t to the fourth. I'm putting it in as x is minus 11t to the second. I keep losing my x to the second. Okay, you can tell that this is not my normal calculator. Okay, 2. There we go. Plus 9t minus 2. Make sure you typed it in right. I did. Square 2. Okay, so that's it. Zoom 6 seems good. Oops. Zoom 6. Zoom 6 is standard, negative 10 to 10, negative 10 to 10. I also sometimes like Zoom decimal. On my other calculator, it's from negative 4 to 4, but this one, it's a little bit different. Okay. Do I need to see any more? I really just need to see above and below. So I'm thinking that I'm actually looking at too much right here. So this is what I'm thinking. I'm thinking that this is going to loop here. But I don't really care about that because I really want to know where right here it goes. So I feel like maybe I'm going to make my window 1, 2, 3, 4, 5. Negative 5 to 5. That might be 4, but whatever. 5 is over here. And then I'm thinking negative 2 to 2. I think I'm going to see it better because I can't tell if that hits once or hits multiple times. So negative 5 to 5, negative 2 to 2. So that's my plan. And then let me undo my, so this is save. Okay, so let me change my window. We said x values was sideways. So I think I put negative 5 to 5. And then, and if you use the enter button, you don't have to, it writes over the numbers that are in the other one. So if you had like 100 and then you use the enter and you just type in 2, it erases the whole 100. If you use the arrows, it doesn't do that. So I'm hitting the enter button. Okay, negative 2 to 2. See, it made the 0 go away. And then I'm going to hit graph. See if I like that better. Okay. Ooh, it doesn't hit at all. Oh, that was deceiving. Oh, that's so deceiving. Wow. I was expecting it to hit twice. Okay. And then also, why am I doing negative 5 to 5? Let me just do negative 3 because that's the bounds in the problem. Okay. So negative 3 to 3. Okay. Oh, that was funny. That's amazing. That's so mean. Look at that one. Oh, I don't think it hits. Now, if I wasn't sure, let me change negative 1 to 1. Okay, that's so cool for the y values. That's such a trap. Oh, definitely does not hit. Wow, that's crazy. Okay, so let me take a picture of this so I can write on it for you. Okay, so we said we're going to do above and below. Okay, so we're doing above and below. So it's above from negative 3 until wherever this value is. which I'm not sure I needed. I think it said how many times do I change directions. So I'm going to call this A. If I needed it, I would use zeros or type in y equals 0 as like y2, and then I could do intersect because I like intersect better. And then it's below, even all the way there, it's below. It's below all the way until right here, B. So it's below until B, and then it's above again. And then there's 3. Interesting. What a fascinating one. That's so neat. Okay, so if a question similar to this, where I wanted, say, a picture or some information about the velocity, where is it moving right, where is it moving left, and finding the values, I would definitely need the picture. Okay, so I'm going to hit save. I'm going to go back over here to our PDF, our write on PDF, and let's see. Okay, so let me draw the picture that we came up with the bounds. So we did those bounds, and then we did -1 to 1. Okay, so we were way up. We hit right here. We called it A. It was way down. And then up here, it comes up again, loops, and then comes here, and that was B. And we could just draw a little dash or something. It is connected, but it's really low. Put it low. Okay, so then VV means you're going above and below. Okay, so the part that's below. Okay, so this part's below, 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 below. So here we have A, here we have B, all of that is below. And then here we go from B, and right here that's plus. And this is also above, and those are the only above places. I'm doing above and below because the labels are the same. Okay, now this, just to remind you, because we haven't done these in a while, but I think you remember, is positive means you're moving to the right, and then this means you're moving to the left, and then positive again means you're moving to the right. No reason for me to write on the bottom versus the top. I was just happened to write. Okay, so where does it change direction? Changes it at A. If I needed the value, I would find the value. And B, and those would be zeros, or type in y2 equals 0 to find those. So 2. Okay. Wow. If you were trapped by that one, I can understand. Okay. Okay. Okay, okay. Twice. Okay, good. So let's go to the next one. On the graph, the slope at any point is twice the value. Okay, slope twice the value of x. Oh, so m is 2 times x. I'm going to call m dy dx because I feel like this is a separation of variables problem. If f of 2 is 3, what's f of 3? Okay, I could do this as a separation of variables problem. 2x dx. Integral, integral. So y equals 2x squared over 2 plus c. Y equals x squared plus c. And that would be 3 equals 2 squared plus c. I'm writing this point right here as 2, 3. So 3 equals 4 plus c. C equals -1. And they want f of 3. So y equals x squared minus 1. And let's just check. Take the derivative. The slope is twice x. Yeah, it's twice x. Okay. And then 2, 3, plug in 2, get 3. Okay. So then I need to substitute 3 in. So 3 squared minus 1 is 9 minus 1, which is 8. C. You know, sometimes there's hard questions and sometimes there's friendly questions. So I think that one is a pretty friendly question as questions go. Let's see. Let me just make sure with Mr. Calculus that I didn't make an error. I was thinking that was going to be an accumulation function. If the equation was more complicated, I guess that would have been. Yeah, he also got C. Okay. The arrows, consider the person who's reading it is an actual person. Okay, so the person who's actually reading is a person. It's okay if you use arrows, they can read arrows. Okay, it's not a computer. Okay, 87, an object traveling in a straight line, if the initial position, okay, this is an accumulation function. Velocity, because this is not something I know how to take the antiderivative of. So let me tell you about accumulation functions. We haven't really talked about them. An accumulation function is when I'm feeling like taking the antiderivative. I really would like to take the antiderivative of v because I want position. So that's my plan. But I look at the equation and I think I want to take the antiderivative and I can't take the antiderivative because either it's a picture, which it's not in this case, or it's an ugly equation. So I look and I can't take the antiderivative. I try again. I can't take the antiderivative. And to me, that is an accumulation function. An accumulation function looks like this. Basically, the idea is, let me do it with heights. The height of a kid, not a kid, let's say a young adult like yourself. So the height at age 18 is your height at age 0 plus the integral of the changes in your height, we'll put t, from 0 to 18. Now what's cool is this works for anything. Okay, so this is v of 18 is v of 0 plus the integral 0 to 18 v prime of t dt. It works for anything. It works for f. F of 18 is f of 0 plus 0 to 18 f prime of t dt. The key is the inside of the integral has to be the prime. Okay, so I want the integral of v. So s, I guess I shouldn't call it s because they want it to be called x. So x of 3 is x of 0. That's the one they gave me. I also put them in order. So even if they had given me the 3 and wanted the 0, I would still put it like this because I like the 3 first. Okay, so my height at age 3 is my height at age 0 plus the integral from 0 to 3 of my changes in height. Okay, so x of 0 is 2. X of 3 is what I want. And then this, the x prime is v. So what I've done is I've changed it to be able either to look at a graph if it was one of those graph given problems, or in this case, I've now changed it from not knowing how to take an antiderivative, because that's an impossible antiderivative, to being able to type it into my calculator. So that's it. I think you guys can type this one into your calculator. So I'm going to use my phone calculator instead, okay? Let's see. Wabbit Emu, where are you? Okay, Wabbit Emu. Okay, so let's see. So 2 plus math 9, 0, 2, 3. And then the cube root. Okay, so where do you find the cube root? I think I would do 1 plus t squared to the power of 1/3. Let's see if that works. And one of my students told me once, if, I thought it was an interesting point, she said, if this looks too ugly, just put that in y1. And she was telling me if it was a quotient, she would put the top of the fraction, the numerator, in y1 and the denominator in y2, and then she would, in y3, put y1 divided by y2, and that's what she would take the integral of. I'm not sure I want to do that, so I'm going to check if I can do it just straight. Close parentheses to the power of 1/3. Oh yeah, that works real nicely on these calculators. Let's just make sure I typed it in right. 1 plus t squared, 1/3. Also on the math menu, there's probably a cube root. Okay, let's see. So this is this on the calculator. I did type the 2 in, is 6.512. And let's see, 6.512 is answer choice D. So cool. Okay, so this is just info. You wouldn't have to write this on a free response. Okay, let's see. Interesting. Accumulation functions show up a lot. I said they took them off of AB, so I don't know. They show up randomly in lots of places. And I guess there's other ways to solve those questions, but I use accumulations a lot on the BC test. Okay, let's see. So 88, for all values of x, the continuous function is positive and decreasing. Okay, so that means the slope is negative and the function is positive. Okay, let g be the function given by an integral. Okay, makes me feel like Leibniz. Which of the following could be a table of values for g? Okay, maybe not. So let's see. So g, I know 2. G of 2, 2 to 2, f of t, dt should be 0. So I would say g of 2 is 0. G of 2 is 0. Oh, seriously, every single one? That sucks. Okay. Okay. Darn. Okay, f is positive and decreasing. Okay, so interesting. So let's look at a picture of a potential f, I guess. Okay. It makes me want to take the derivative. I just like Leibniz. Let's take the second derivative. Let's take the derivative. Okay, so g prime of x, substitute in the top, so that's f of x times 1 minus f of 2 times 0. So g prime of x is f of x. And g double prime of x is f prime of x. Okay, so what this information is really telling me, this one is telling me g prime of x is greater than 0. And f prime is g double prime, so g double prime of x is less than 0. So I really don't care about f now. I really only care about g. I think I should graph them. Graph them. 1, 2, 3. So 1, negative 2, 2, 0, 3, 1. So is g prime greater than 0? Oh. Locator tag. No, I don't know what I did. I hit something. Okay. Increasing. Okay, so g prime is greater than 0. I feel like it's concave. This is 1, this is negative 2. I feel like it's concave down. It's supposed to be concave down. I kind of like A. Okay, let's see. I don't like when it's A, though, because when it's A, then I think, well, am I really right that it's A? Okay, so this is negative 2, 2, and then 3. So let me try to draw this to scale 3. See, that's concave up, because if it was a straight line, it would go like this. Like if this one was a straight line, it would go like that. So that's definitely concave down. This is definitely concave up, at least for parts of it. Okay, so I'm going to go with no, because this says concave. This says concave down. Not this one. Don't look at this anymore. Okay, so concave down. So I'm going to say B is wrong. Okay, so this one, 1, 1, 2, 0, 3, negative 2. Okay, g prime is less than 0, and g prime was supposed to be greater than 0. So I would say this is not the answer. Okay, this one, let's see. And I'm starting to think it's A, but I really want to give these another chance because maybe I'm not thinking of something. 1, 2, 2, 0, 3, negative 1. Okay, that's g prime is less than 0, so that's a no. Let's see this one, 1, 3, 2, 0, 3, 2. Oh, cool. No, it's not always decreasing. So this one was bad because a concavity. So this was concave up, and this was concave down. If you want to redraw A to scale, you'll really see the concavity that it bends up compared to a straight line. Okay, so that's 88, and 88 is A. Okay. Mr. Calculus did it some algebraic way. It looks way more complicated. Like way, 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 way more complicated. The picture is really helpful. Okay, 89. Okay, So 89 we have, okay. I feel like it's intermediate value theorem or Rolle's theorem or something. But let's see, let's draw a picture. So these are both 0. That feels like Rolle's theorem. There is no C. There is no C. Okay, so this definitely sounds like a theorem. Where f prime of C is 0. So the slope's never 0. So what if I went direct? The slope's 0 everywhere. Well, what if I go up and then I go down? The slope is 0 somewhere. Now that's Rolle's theorem. Okay, Rolle's theorem is if your two y values are the same, your slope somewhere in between has to be 0. So it must violate one of the conditions. So our conditions for Rolle's theorem is 1, f has to be continuous on the closed interval, so -2 to 2. And 2, f has to be differentiable on the open interval, -2 to 2. Then, and for Rolle's, there's a 3. You need f of b to equal f of a, which this does. Then, it's the same as mean value theorem. Okay, so this is Rolle's. Okay, and Rolle's is the same as mean value theorem. So that's f of b minus f of, the slope between the endpoints. Okay, so we'll call it what I was calling it for you. So algebra slope equals calculus slope. So the algebra slope is 0, and the calculus slope would be f prime of c. So it must violate one of these two conditions. Let me highlight them. Oops, highlighter. Okay, so it must violate the continuity, or I meant to use yellow. It must do the differentiability. So let's see. Okay. So I feel like it might be E. Let me get back to a color, like an actual pen. Let's see. Exists. No, there's a problem. Less than 0, greater than 0. No, it has to do with the conditions. Okay, f prime exists, but f prime is not continuous. Oh, it does say f is continuous, so it's not this one. Okay, so f must not be differentiable. Well, let's draw a picture. How about an absolute value? The derivative does not exist. I like E. Okay, Mr. Calculus agrees with me with the E. So we're going to go with E. I don't know what they're talking about for D. It exists, but it's not continuous? I don't know. Okay. Sometimes those theory questions, though, they get me, and I have to convince them myself into the answer. So I did go with E before I looked. Okay. So let's see. The next one. Oh, a chart. Oh, I like the chart ones. Okay, derivatives. Oh, this one. Oh, this is an AB question. Slope of the graph of h at 2. So they want h prime of 2. Oh, I like this one. So h prime of x equals derivative of the outside. Keep the inside inside times the derivative of the inside. Chain rule. H prime of 2 is f prime of g of 2 times g prime of 2. So f prime of g of 2 times g prime of 2. Okay, so g prime 2. So g of 2 is -1. G prime of 2 is 2. And now f prime of -1, f prime, -1 is 3. 3 times 2, 6. 6. Let's see, Mr. Calculus, what did you get? You also got 6. Okay. I want to ask Mr. Calculus His name is Mr. Alcosser. But I want to ask him, he and I have been friends for years, math friends, teacher friends, before he retired. And I really want to ask him about what he thinks about the AP test. Okay, I should call him. Okay, let's see. Okay. Ooh, I do not take the integral of that. Yuck. Okay. At which of the following points does it have a relative maximum? F. Oh, and F is an integral. Oh, feels like Leibniz or second fundamental theorem of calculus. You substitute, that's because maximums, right? I need F prime. I want an F prime number line. So the derivative of that is substitute in the x times the derivative of the bound minus substitute in the x times the derivative of the bound. So that's 0. Okay, so f prime of x is cosine of 1 over x squared. And I would like a number line. I want a number line. So I want a number line from 1/3 to 1. That's way too big of a number line. And then I want f prime because I want a relative maximum. And they want to know what x value, so they don't need the y. So what do you think? What am I going to say? I'm going to say that's a graph given problem. Now, is it really a graph given problem? No, because there's no graph given. But I can give myself a graph. So I'm going to give myself a graph. Okay, so 0 would be over here. Here's 1. I really made that way too long. Okay, so how am I going to graph that? Let me graph that over here on my calculator. Let's see. You guys graph it at the same time, okay? So cosine 1 over x squared, close parentheses, make sure I'm in radians. Okay. So that graph's only from 1/3 to 1. So I'm thinking zoom decimal. Let's see, zoom decimal. Okay, that is ooh, weird, cool stuff. Okay. Only from 1 to 3. Okay, you gotta watch that graph though, okay? You gotta watch that graph. Okay, so it was like so boring. It was like a horizontal line it looked like, and then all of a sudden it did a weird like heartbeat thing. Okay, so let's see. I know I get a little too excited about graphs. Okay, 1/3. And I think math in general. Okay, 1. Okay, let's see. Okay, oh, that's pretty. So it's going like this, and then like this, and then over here, and then it goes like that. Okay? Oh, and that's 1/3. So let me put my axis here. So this is 1/3. And this is 1. Okay, I'll put the y-axis over here somewhere. We don't know what happens over there. Okay, so this is the f prime graph. And this is the f prime number line. So if they're labeled the same, it's the y value, okay, which is above and below. Okay, above is positive, below is negative. So I'm below, and then I'm above. Now that's until here, right? A, and then I'm above until B, and then I'm below until C, and then I'm above again. Okay, relative max. Okay, so let's check. Now, I'm going to change colors because I am graphing something not shown. So I'm now graphing F. So my red is F. Decreasing, increasing, decreasing, increasing. Relative maximum. Is it B? So how am I going to find B? I'm going to have to go back to my graph and then find B using 0. Or you could use intersect. You can make y2 0 and use intersect if you want. Now I graphed this as my y1. This is my y1. Okay, so that's my graph. Very interesting. So it would be B and only B. Okay. So second calc. Oh no, let me go to y equals. Let me add. Oh, I hit delete. Shoot. Okay. Cosine 1 over x squared. That's x. Okay, then 0. 0. Okay, so I'm making my y2 0 because then I can use intersect instead. Okay, that's just a little shortcut because I like hitting enter, enter. Okay, now it's graphing again. Graph, 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 graph. Okay. You guys, you should have seen the old calculators. They were so slow. Okay, so enter, enter, and then I need to see which one. Oh, that one right there. So like the bottom of my hill there. Hit enter. Okay. It's very difficult to see. So this B is 0.460658887. Okay. And so it says X value. So that would be 0.461 because that would round up. So D. If you wanted to know the actual maximum, you would have to substitute it into the main equation. And that is also what Mr. Calculus got. Okay. And we only have one more. Oh, that's so sad. Okay, what time is it? Okay, it's 12:10. I guess it's not so sad. Okay, so let's do the last one. Multiple choice. Graph given. This actually is a graph given. Tangent lines. Tangent lines, another line. I don't think I've ever seen this question before. Okay, so let's see. The figure above shows the graph. The graphs of the line tangent to the graph G at x equals -3 and x equals 1 are also shown. Okay. If b of x is g of f of x, what is b prime? Okay, well, let's not look at the picture for right now, and let's find b prime of x according to the formula. So this reminds me of one we just did. So g prime of f of x times the derivative of the inside. Okay, and it says, what is b prime of -3? So g prime of f of -3 times f prime of -3. Okay, so now I need stuff at -3 at the moment. So I want f of -3, and I want f prime of -3. Okay, and the graph above is f and g. Okay, let me look at f first. So this is f. So what's f of -3? Okay, that's the y value, right? F of means the y value. So -3 looks like right here, 1 is the y value. And they also want to know the slope. So the slope right here, I wouldn't know what it was, except this is a line. So I could use rise over run. And that's not an estimate, that's actually the line. So rise would be 1, run would be 3, positive. Okay, so this is g prime of 1 times 1/3. Okay, g prime of 1. So that is the slope of g at 1. So here's 1. Now is that that is, they said the tangent line at 1. So what is the slope of that? Well, kind of down 1, right 2. So I guess g prime of 1, yeah, and I definitely want 1, is the slope, right, of g at that spot. So I would say it's down 1, right 2. So for rise over run, that would be -1, +2. So -1/2. So let's see if that works. -1/2 times 1/3 is -1/6. B. And yes, that is the same answer that Mr. Calculus got. Cool. Usually I would just look at the answers for 2008, but like I told you guys before, the answers for 2008, I can't find them. All it keeps giving me, I don't know why the internet, usually it gives me the answers, but it keeps giving me the AB answers. And then it just has the BC like interspersed. It's very strange. Anyway, so that's the end of 2008. So you guys are ready to take the mock multiple choice. Once you finish this, you go through this, study some formulas, and then maybe that's the last multiple choice we do. We'll have to see because the test this year is only free response. So we'll see. And if you want, maybe we can do multiple choice as a overall review, maybe, you know, a week before the test, just to check all your little tiny topics in case they show up on the 45-minute test that you have. I think you're going to do fine. And then we're going to study the free responses, and we have a specific aim. If we were also taking the IB test and then only taking free response BC, that might be a different story, but we're not. So I think in the end, everything will be fine. You guys got this. We don't know how IB's grading, so we won't know. So we have absolutely no idea. So we'll see. Hopefully, you know, you guys did get decent grades on your IAs, but I think your predicted scores are higher. So, or the same. No, I think nobody's IA was higher than their predicted grade. I'm not sure about that though. I'll have to check. Anyway, good night. It's 12:15, so I'm going to post these on, I'm not going to post them in our group chat because you guys might be asleep, but I am going to post these right now in the playlist. So if you are still awake and you're seeing them, they're going to show up. Okay, and I'm going to have both of the last two videos. Okay, good night.